तो हमने चैप्टर 2 और 3 कंप्लीट कर लिया पीडीई का। चैप्टर 3 में बेटा थियोरेटिकल है थोड़ा, ठीक है, प्रूफ बेस्ड है। सो थ्योरम्स आती है, सो उसकी प्रूफ्स अब कर लेना, ठीक है। उसमें बेस्ड थोड़ी सी एप्लीकेशन आएंगी एक्सरसाइज के, सो जस्ट गो थ्रू इट। क्वेश्चंस में जहाँ पे भी जो भी डाउट आ रहा है जस्ट मार्क इट और उसके बाद मुझसे पूछ लेना, ठीक है। वी आर स्टार्टिंग अ न्यू चैप्टर, चैप्टर 4। दिस इज वेरी इंटरेस्टिंग चैप्टर। along with it there are applications in it। मतलब जितनी एप्लीकेशन बेस्ड क्वेश्चंस इस चैप्टर के सॉल्व कर सकते हो यू कैन, ठीक है क्या। हमने चैप्टर 2 में कैनोनिकल फॉर्म किया था। वी हैव डन द कैनोनिकल फॉर्म फॉर द फर्स्ट ऑर्डर पार्शियल डिफरेंशियल इक्वेशन। when you have a form of a ux plus b uy equals to some c, we have solved the canonical form there. Now we'll talk about here the second order PDE, and we'll find the solution using this canonical form. So there, the question will be asked that the given PDE, second order PDE, find the region, whether it is parabolic, elliptic, or hyperbolic, and along with it, find the solution using the canonical form. That means canonical form means basically we have done the transformation of x and y into another variables, just like we have done the transformation here in the first order PDE when we have found out the characteristic equation, and there the solution of that one characteristic equation we put as xi and another we took eta as y. X और y की terms में we have considered xi and eta so that their Jacobian is non-zero. We'll find the Jacobian here as well, ठीक है. It should be non-zero to find the solution in the form of xi and eta. This is what we are going to do today. We are going to follow the most basic concept of chain rule. We have done that already. Suppose I am taking sine of root x. How do you apply here chain rule to find the differentiation of this? Suppose you have to find dy upon dx. What you'll do? You'll find the differentiation of first sine, correct? What is the differentiation of sine? Cos. You'll put the angle as such, correct? Now next will be, you'll move on to the angle part. Angle part here is root x. What will be the differentiation of root x here? 1 by 2 root x, correct? If I do it another way, that means if I put over here root x as some theta, it will become y equals to sine theta. I have to differentiate this with respect to x. This will not change, correct? Because you have to do the differentiation with respect to x. Now, if I do the differentiation dy upon dx, what will happen? Because y is in terms of theta now. So you will differentiate y with respect to theta first, and theta you will differentiate with respect to x first, correct? Check what you are getting over here. Dy upon d theta, y is sine theta, that differentiation will be here. Its differentiation will be cos theta and d theta by dx. Theta is root x. What is the differentiation here? D theta by dx will come 1 upon 2 root x. If we substitute the value of theta here, theta is what? Root x. So if we substitute the value over here, theta as root x, will I get the same answer as I'm getting here directly? This was using the parametric form that we have done in 12th grade already, that we substitute x equals to cos t, y equals to sin t, and then we differentiate with respect to x. Here also we are going to apply the same rule. If you see over here, if you observe this, that y was first in terms of theta, and that theta was in respect to in terms of x. And you have to differentiate with respect to x. You move to theta first, and then to x, correct? Here also, we are going to do the same thing, but the difference is it will include second order. That means two variables. So previously, we used to have u in terms of x and y, and we have differentiated it with respect to x and y singularly here, like this. Now what we'll do, we'll differentiate it again. So what we'll get? What kind of terms you will get? Ux, first differentiation. Uy, first differentiation, but with respect to y. Or uxx, you differentiated ux with respect to x again. Similarly, uyy, uxy, uyx. 1 minute. Okay, so if we differentiate this u with respect to x, then again we differentiate with respect to x, or we differentiate with respect to y. So we'll get these kind of terms, correct? Right? So these type of terms you will get in the second order PDE, right? Now suppose u is in terms of x and y, and I have substituted x and y in terms of some xi and eta. That means, if I show over here, I substituted x or y term as some xi here. That means this xi I'm writing in terms of x and y, and eta again I'm writing in terms of x and y. Just compare it with the second order equation. I have substituted y equals to sine theta, and theta was my root x. That means y was in terms of theta and theta was in terms of x. Single variable here x. But here u was in terms of xi and xi was in terms of x and y. That means there are two variables coming over here. Similarly with u, when in terms of theta, we are having theta in terms of x and y. Alright. हमारे पास u था xy. Now it is coming as theta. Sorry. Okay. It is clear till here that u will write in terms of xi and eta, where xi and eta will be the functions of x and y. Okay. Now, suppose u I have written in terms of xi and eta. Now let's find del u by del x and del u by del y now. What will happen? Del u by del x if you have to find. You know very clearly u are in terms of xi and eta, right? And you are differentiating with respect to x. So you have to reach from here to here and from here to here, right? So that means first you will differentiate with respect to xi, and this xi with respect to x plus, now let's talk about eta. There's another variable now. Del u by del eta into del eta by del x, because eta is also in terms of x and y, right? Now let's find del u upon del y. What will happen to del u upon del y? Again, u xi to y and u eta to y. Del u by del y will be what? Del u by del xi into del xi by del y plus del u by del eta into del eta by del y. We move on with both the variables. Okay. Now del u by del x and del u by del y, I have to differentiate again. What will happen to that? Because here we are talking about second order PDE, so we have to find this uxx, uyy, uxy, uyx, right? Let's check what will happen. Now this del u by del x. This del u by del x will also again will be in terms of xi, eta, x and y, right? That means this del u upon del x, when you have to find the double differentiation, that means you have to again differentiate it like this. So what will happen? What you will do in that case? Okay, so it will come del u by del x is del u by del z into del z by del x plus del u by del eta into del eta by del x. Now you have to differentiate it with respect to x and y, right? So now you have to differentiate with respect to x. See what that will become. Equals to This is your del u by del x, correct? So del by del x of what you will do? Del u by del z into del z by del x plus del u by del eta into del eta upon del x. How will you differentiate this now? I'm doing this. You will differentiate del u by del x with respect to y, this with respect to y, and with respect to x. These three you will do. Okay. I'm just showing it over here, how you're going to use it over here. So you have to differentiate this whole by del x. Let's first talk about this. I know this del u by del z is a function of y as well as x and y, correct? If I talk about del u upon del z, this del u upon del z is a function of xi and eta and is a function of x and y. Okay. So what will happen? This, let's talk about, because there is this dot, that means there is this product. So we apply product rule. Del z by del x as it is. What we'll do? First, when del z by del x I kept as such. Then if you differentiate this del z by del x with respect to x, it will become what? Del square z by del x square, and the first one, which is del u upon del z, will remain as such. Okay. अब del u by del z को differentiate करने पे क्या आएगा? See, with respect to x कर रहे हैं, and how we are going to follow? x पहले y से जाएगा, फिर eta से जाएगा. So first you will do what? This del u by del z will become del square u by del z square. Del z by del x I'm keeping outside. Okay. Thus, now del u by del z, I know that it is also going from eta to x. So what will you do? Del u upon del z को आप eta के रिस्पेक्ट में करोगे पहले, it will become del square u del eta del z into del eta upon del x. Can you observe how we are coming to this? ये important part है बच्चे. Because this xi del u upon del z is also function of eta, so I have differentiated with respect to eta, so it will become del square u upon del eta del z, and this eta will be differentiated with respect to x, so it is coming over here. That's it. These three terms will come. Okay. I hope till here it will be clear to you. Now moving on to the next part. What will happen to the next one? Try it out. Eta, del u upon del eta is again the function of xi and eta. Plus, again let's apply the product rule. Del eta upon del x as it is. Then again, if I differentiate with respect to x, it will become del square eta by del x and del u by del eta as such, according to the product. Plus del u upon del eta into del eta del square eta upon del x square. And del u upon del eta. Now you are differentiating with respect to x, so it will become what? Del u by del eta again. This del u upon del eta again in terms of xi and eta, and this xi in terms of x and y, and this eta in terms of x and y. Now we have with respect to x again, but in case of eta. And I know this del u upon del eta is also a function of xi. So how will it look? This del u upon del eta when I differentiate with respect to x. Del u by del eta I differentiate with respect to xi. It will become del square u upon because I'm differentiating with respect to xi here, which I'm differentiating del u upon del eta. Plus, now I'm to differentiate with respect to, sorry, del xi upon del x, because increase del xi by del x plus del square u upon del eta square into del eta upon del x. What will remain outside? Del eta upon del x. See here carefully. This was u, this was kind of v, right? U का differentiation किया, जो भी term bracket में आई, that will be my answer. V as it is. तो u को differentiate किया, यहाँ पे sorry, u को differentiate करके v as it is लिखा था, then v को differentiate करके u as it is लिखोगे. Then u upon del eta वो as it is लिखा है यहाँ पे here, right? So these kind of terms you will get whenever you differentiate this del u upon del y with respect to y or with respect to x, or this del u by del x when you differentiate with respect to y. Yeah, वो पता होना चाहिए how you are coming over here with this. Okay. Now, how the transformation of the second order PDE will look? Transformation, that means you are transforming x and y in terms of xi and eta, right? So basically, uxy, that means del u by del x, del u by del y, del square u by del x square, del square u by del y square, or del square u by del x del y, or del square u by del y del x. Although the last two both are equal, right? So how will they look when you are transformed x and y in terms of xi and eta? Eta is also will become a function of x and y. If you don't want to take xi and eta, take this as f and g, so that you will not get confused. Function f and g. Alright, no problem. So how will they look? You differentiate, that means you'll get del u by del z term, you will get del u by del eta term, you get del square u by del xi eta, or del eta del xi, or del square u by del eta square. Del square u by del xi square. Correct? Now let's talk about the canonical form of the equation. So the equation will be like this, which contains of these kind of terms. So what I'll do, I'll just like there in the first order PDE, I have written AUX plus BUY plus C or equals to C, where A, B, C were the terms which are including the variables X, Y, and U. Here I'll represent the same thing, but with different variables. R plus S plus T equals to U, where the small r will be del square u by del x square. This small s will be del square u by del x del y. And the small t is del square u by del y square. Okay? We capital R, capital S, capital T क्या है? They will be the functions of x and y. And this u, what will be this u, capital U? It could be the function of x, y, or z, or that del u by del x, del u by del y. That means that P and Q, which we have considered in the second chapter already. Right? Like this. Okay. Here, R, S, and T are the functions of x and y. Now, based on these capital R, capital S, and capital T, which are the coefficients of double differentiations, on the basis of R, S, and T, I could tell whether the given equation will have the region of a parabolic curve, or hyperbolic curve, or elliptic curve. That will be determined by the equation if this s square minus 4rt, जैसे quadratic equation में करते थे ना b square minus 4ac, just like that, Here, if you find s square minus 4rt and it is greater than 0, the region will come hyperbolic. If s square minus 4rt is equals to 0, the region will be elliptic. This you have to keep that in mind. That, and if s square minus 4rt is less than 0, the region is parabolic. So first, the question will be there, what kind of region the equation is showing. So you have to check this s square minus 4rt, whether it is greater than 0 or less than 0 or equals to 0. The question 1 of this exercise is on that only. We'll try first. Let's talk about how you will solve if the equations are given to you. पहला question देखते हैं. First case, when your equation is hyperbolic. How will you find the solution? We'll do the examples along with it, then we'll consider the another two cases which are left, which is parabolic and elliptic. Alright. So that when you're understanding how to do these steps, you'll also get to know how we are going to apply it in the questions. So first what we are doing over here is, suppose this equation is given, right? So what you're doing, going to do first, just like the previous time here, we'll check s square minus 4rt. S square minus 4rt. For the hyperbolic equation, it should come greater than 0. If it has come, we'll take a quadratic equation with coefficients r, s, and t, which will be r lambda square plus s lambda plus t, where lambda will be any real function, where lambda is any real function which depends on both the variables x and y. Okay. Now we'll be able to find the roots of this equation. It is a quadratic equation, so it will have two roots, whether they are equal, whether they are distinct, right? Or they're complex, whatever they are. So second, next case, what you're going to do, third one. Let the roots of the equation be lambda 1 and lambda 2. All right. Next part, you will consider a differential equation for these lambda 1 and lambda 2, so that when you solve, you will get the functions of two functions which will be in terms of x and y basically. So you consider the differential equation. The equation dy by dx plus with the given solution that you have found, lambda 1 and dy by dx plus lambda 2 x5. They will be in terms of x and y. So you have to use separation of variables or any other method to find the functions which will come in terms of x and y, right? So let us assume the solutions of these two differential equations is f and g, where f and g are again in terms of x and y. And you have got the two solutions which you can consider as I and f. That's it. And we're done. We'll solve it further, but we've done to find the steps to find psi and eta basically. All right. Next step, the fifth part will be lambda the solution. Let's say the solutions of above differential equation as lambda 1 equals to fxy, say, and lambda 2 as gxy, say. Then this f, consider this f as xi and eta as g. That's it. Then we'll differentiate, we'll find the solution here. Basically, small r smallest and small t will be double differentiations. So what you'll do, you'll double differentiate and differentiate these, and you will substitute there, and you will get your equation. See how we are solving. I'll show you the example over here. In this example 4.3.1. Consider the equation 4uxx plus 5uxy plus uyy plus ux plus uy equals to 2. Don't get scared with this ux and uy. We have considered already that equals to u. Equals to u. This u could be in terms of anything. This u here can be written as del v by del x, del v by del y. Right? I'll write over here. This u would be the function of p, q, x, y. Right? Another variable z can also be included there. Okay, so जो भी remaining part है, that will be considered as u. Okay. Now, we have to look at the equation r plus s plus et. Correct? What is r, what is s, what is t over here? Check. The small r was uxx. This smallest was uxy. And this uyy is small t. So, by comparing, we get capital R as 4, capital S as 5, and capital T as 1. Check S square minus 4RT. Coming out as greater than 0, and we have done that if it is greater than 0, the region is hyperbolic. Because this is coming as greater than 0, so the region is hyperbolic. Achha, you just have to do this part in question number 1 of the exercise. So do try it. You just have to tell whether the region is elliptic, hyperbolic, or parabolic. Okay. Now, what will be the characteristic equation? Tell the characteristic equation, which includes R, S, and T, and the real function lambda. R lambda square plus S lambda plus T. No R, S, and T. Substitute 4 lambda square plus 5 lambda plus 1 equals to 0. Now let's find the solution. I'm leaving it out to you. What will be the solutions? Values of lambda. Try this. You will get minus 1 upon 4 and minus 1. Right? So, to find the solution, or you can say xi and eta, what you do? You consider the differential equation. Consider dy by dx plus lambda 1. What is lambda 1? Minus 1 upon 4. And another differential equation will be this. Find out the solution. I hope you'll reach over here, right? So y minus x upon 4 equals to c1 and y minus x equals to c2. Correct? You can put psi and eta here. You've got psi and eta. Let xi equals to y minus x upon 4 and eta is equals to y minus x. Such that whenever you find the Jacobian of x and y, that means del xi by del x, del xi by del y, del eta by del x, del eta by del y. It should come out to be non-zero. You try it. Okay? Now, what is del xi by del x? What is del xi by del y? Minus 1 upon 4. Del z by del y is 1. Del eta by del x minus 1 and del eta by del y is 1. Right? And here we have done. Now I know that u will be the function of y and eta. Correct? U consists of y and eta. I'm doing it in terms of here x and y, which are in terms this xi and eta in terms of x and y, and this u will be in terms of y and eta. Why I'm doing this? Find the solution in terms of the canonical forms is xi and eta. Now coming back to the given equation, it is uxx, uxy, uyy, ux, and uy. Okay. Now I have to substitute this value uxx, uxy, uyy, ux, and uy in the given equation. For that, I need to know what is uxx, what is uxy, what is uyy, what is ux, and uy. So let's find it out. Just like we have done over here. This same thing we are going to do again. Alright. So here we'll find del u by del x first. What is u? What is the value of u? Tell me. Find del u by del x. U is a function of xi and eta, correct? Where xi and eta are functions of x and y. We have to find del u by del x. Then again, I have to differentiate it with respect to x. Then, and also we have to find uxy, uyy, ux, uy, correct? Del u by del x. We've done it already. It will be what? Del u by del xi into del xi by del x plus del u by del eta by del x. We know the values here, del xi by del x and del eta by del x. What are the values? Del xi by del x is minus 1 upon 4 and del eta by del x is minus 1. Put those values. You will get the value of del u upon del x as what? Minus of del u by del xi and minus 1 upon 4 del u by del eta. Now I have to differentiate it again. So what you'll do? That means you have to find del square u by del x square. That means you have to differentiate this part and this part again. Again, del u by del xi is a function of what? Del u by del xi is also a function of xi and eta. And again, xi and eta are functions of x and y. So if you have to differentiate it with respect to x now, that means you have to go through this xi again. Again, if you have to differentiate with respect to x, that means you have to go with eta as well. So again, do it minus of what? Here, del u by del xi. It will become what? Del square u by del xi square into del xi by del x. Right? Minus 1 upon 4. What will happen to this del u by del eta? It will become what? Del square u by del eta square. But here you have this del u by del xi. It is also a function of eta. So when you differentiate it with respect to x, here you have to differentiate with respect to eta again. So what it will become? Okay, let's write first terms differentiation first. That means this will be differentiated with respect to eta now. Right? Del eta by del x. No? We're differentiating with respect to eta now. Now minus 1 upon 4. Del square u by del eta square del eta upon del x plus del square u by del eta को यहाँ पे del u by del eta को del xi के रिस्पेक्ट में डिफरेंशिएट करोगे तो it will become del square u by del xi del eta del xi by del x. Now again substitute the values which are given. See what you what is the value of del xi by del x? Substitute again del eta by del x minus 1 upon 4 and minus 1. So it will become what? 4 minus of del square u by del z square del xi by del x. Del xi by del x is minus 1 upon 4. Okay, I think changed the values here. It was del u by del z by del x is minus 1 upon 4 and del eta by del x is minus 1. Okay, so here again you have to do that. Minus 1 upon 4 of this. This will become minus 1. Alright, now del y by del x is what? Minus 1 upon 4. Put the value here. Del square u by del x square will become minus 1 upon 4 or minus 1 upon 4 del square u by del y square minus del square u by del eta del y minus of del eta by del x is minus 1, right? Minus del square u by del eta square and del y by del x is what? Minus 1 upon 4 del square u by del y del eta, right? Okay, so what we're getting, if you open it, 1 upon 16 of del square u by del y square, it will become plus 1 upon 4. Taking this value along with it, plus 1 upon 4, it will become 2 upon 4. Del square u by del y del eta del y. Because u, we are talking about a continuous function. So double differentiation with respect to xi eta or eta xi, they'll be equal. And the last term will be minus plus del square u by del eta square. That we have reached here. We have got uxx, right? Mark it as 1. Now, just the similar way, find out uxy. See, that's uxy. That means you have to do del u by del x first and then y. That means you have to differentiate with respect to y. Del u by del x, we have found already this, right? Now, ux was what? Minus 1 upon 4 minus 1 upon 4 del u by del z minus del u by del eta. Now I have to find uxy. That means this del u by del x, I am going to differentiate with respect to y. Del square u by del y del x I have to find. Correct? Now I am differentiating with respect to y. I know again that del u by del xi and del u by del eta again are the functions of xi and eta, and where xi and eta are again the functions of x and y. Right, so I have to go through it again, but now I have to differentiate with respect to y, so I'll go along with this way, So minus 1 upon 4 del u by del z, it will become del square u by del z square into del z upon del y. I have done this one. Now I'll go this way. That means I'll differentiate this by eta now, because eta is also a function of y. I'm using simple chain rule here. Correct? Minus of del u by del eta. Now del u by del eta again is a function of xi and eta. So it will become what? You can write here del z del eta. Let's do it with xi first. So it will become del z upon del y plus del square u by del eta square into del eta upon del y. Done here. Solve it. uxy. See what you're getting. Del z by del y was, you see here, del xi by del y is 1, del eta by del y is 1. Both are 1. So you will get what? Minus 1 upon 4 of del square u by del xi square plus del square u by del eta del xi minus of del xi by del y is 1, right? So del square u by del z del eta plus del square u by del eta square. Correct? So here we have reached. Now open the bracket, solve this del eta del eta. We are getting minus 1 by 4 of del square u by del xi square minus 1 upon 4 and minus 1. They will become minus 5 upon 4 del z del eta and minus of del square u by del eta square. Right? We know ux, y. Now we have to find u by y. And the last part will be ux we have done, uy. Let's find uy first. You will get uy after that. uy. That means del u upon del y. That means you're differentiating with respect to xi first. Xi with respect to y. And then you have to differentiate this u with respect to eta and eta with respect to y. Del z by del y, del eta by del y, we know the value is positive 1. So it will become del u by del z plus del u by del eta. Right? Moving forward, finding u by y, we're getting now del u by del xi. You have to differentiate with respect to xi, with respect to eta both. So let's do it with respect to xi. You get del xi by del x. Now I'm differentiating this again with respect to eta. So I will get del eta del xi because I have differentiated this del xi already, and now I'm differentiating with respect to eta. Del eta by del y. Why I'm writing x here is y. Plus del square u by del eta square into del eta upon del y plus del square u upon del z del eta into del z upon del. Right?
I know del z by del y, del eta by del y are positive 1. So it will become del square u by del z square plus 2 del square u by del eta square del z del eta plus del square u by del eta square. We have known all the values here. One by one, we'll use them. Mark this as 1. Right? Del u by del x, ux6 we have done. Mark it as 2. uxy we have done. Mark it as 3. uyy, 4th. uyy, 5th. So, using all the above equations and substituting the values in the given equation, we get, okay, now from now uxx, what is the equation? If you see, 4 times uxx okay, with ux6, let me write the equation, plus 5uxy plus uyy plus ux plus uy. Four, 5, 1, 1, 1, okay. Right. This is the equation. Let's substitute the values. Uxx was del square u by del z square. I think Uxx was this 1 by 16 of del square u by del z square plus 1 by 2 of del square u by del z del eta plus this del square u by del eta square. Substitute and see what you're getting. And by 16 of del square u by del z square plus del square u by del z del eta plus del square u by del eta square, right? Plus 5 times ux5. ux5 we have got was, I think it was minus 1.4, no? Yeah, minus 1.4 del square u by del z square minus 5.4 del square u by del z del eta minus del square u by del eta square plus ux5 plus uyy. Uyy we have got already here 1, 2, and 1. Plus ux plus uy. Put the values, you get the answer. What is uy? Equals to 2. Now arrange all the values of del square u by del square u by del z del eta, and del square u by del y square. Del u by del z, del u by del eta, they are the single variables, they will remain the same, and collect the terms we will get. So we will extend it was 1 by 4 del square u by del z square plus 2 times 2 times del square. I'm solving it here. You try it on your own. I'm just simply solving it. Positive in the last. Yeah, they will cancel out. Anything else is getting cancelled. See, you observe here, this is 4 del square u by del eta square, this is minus 5. It will become minus 1, 4 minus 5, it is positive 1. So you can cancel it right away. Correct? Anything else? If I see del u by del y, here it is minus 1.4, here is positive 1. There's something which we are missing here. No, correct? No. See. So what will happen? Collect the values of user I, user eta, and user. Right? For del square u by del z square minus 5/4. This value, and end it with another one, this, and this. 1/4 minus 5/4 plus 1. Now this 2 plus 2 minus 25/4, 4 minus 25. Tell you what else 1 minus 1/4. 1/4 use I equals to 2, right? So solving it, check what you're getting. This will get cancelled. This will become 16 minus 25/4 user eta plus 3/4 user equals to 2. Take LCM. 3 user minus 9 user eta equals to 8. Right? So what will be user eta? User eta will become what? 8 minus 3 user minus 9. So user eta will become what? 3/9 user minus 8/9. Your answer has come. User eta as 1/3 user minus 8/9. We have done over here, when the region is a kind of hyperbolic region, the equation of the canonical form will look in the form of what? Have we done it or not? I think we have. When the region was hyperbolic. Okay, we have not done it yet. All right. I'll just tell you how will the equation looks when the region is parabolic, hyperbolic, or elliptic. Alright, here. If you observe, the region is including user eta as user and a constant, right? So whatever the terms of the canonical form in the hyperbolic region will be, they will include user eta, user, u eta, and function any constant or u. Okay. Similarly, we'll find the equations for parabolic and elliptic regions. The observation for the hyperbolic function here. Hyperbolic function, the expression is del square u by del z del eta as functions which will include some u, some xi, some etas, or del u by del xi, or del u by del eta. So you can compare, right? Now let's talk about the parabolic transformation. I'll tell you for the parabolic transformation. I am telling it already to you. We are going to do the steps, the same steps as we've done for the hyperbolic expression. So parabolic transformation will have del square u by del xi square. That means u xi. It will be again function of u xi eta del u by del xi or del u by del eta. right? I'll write the elliptic one as well. We'll do the questions based on all the three. I'm just telling you here, transformation. Del square u by del eta square will come over here. And del square u by del I square, both will come over here. Which again, function of u psi eta, del u by del xi, del u by del eta. Alright. Okay. Let's talk about the parabolic expression. Okay. So when the equation is parabolic, when the equation is parabolic, just like the hyperbolic function, we have checked the steps. Similar way, we will do the same steps. What? Check for the equation as x square minus 4rt. If it is coming equals to 0, then the region is parabolic. Second step, you will find the solution of the quadratic equation, which include r lambda square plus s lambda plus t equals to 0 again. Here you will observe they will have repeated roots because of this. We will have repeated roots. Let it be lambda equals to lambda x. Alright. Next step, you'll consider again the differential equation, just like we've done in the hyperbolic region. The differential equation as dy by dx plus there it is. What happened here? Dy by dx plus lambda of x comma y equals to 0. You'll solve the equation. Let's say the solution we get will say fxy. Now you have to substitute that in xi and eta. So put xi as the function of xy and eta is the function of x or y, anyone, because in the previous one, hyperbolic region, s square minus 4rt was greater than 0, so we have got distinct roots, and for that we have found two solutions where we put both the solutions as xi and eta. Correct? Now we have got only one solution as f. That we have substituted as xi. Now eta, you will take any function x or y independently. It's your choice. Alright, then again, here we know that you use a function of xi and eta will differentiate u with respect to x, with respect to y, according to the differential equation given to us. Okay, and then we'll substitute the values and we'll get the canonical form. By the question. So, as the function of x and y, which is not depending on xi, independent of xi. Alright. Let's do one question based on this. Example number, it's 4.3.2. What is the question? Solve this differential equation, ux plus 4uy minus 4uxy equals to e to power y. Now see here, you have to find this and this and this, and then you will substitute in this given differential equation. Before that, let's find out the region, what it is, either parabolic or hyperbolic or elliptic. So for that, we'll do the first step, which says s square minus 4rt. As the middle one, just find it out. You know it already. You've done it in the 10th grade, I guess. It will come as 0. That means you got parabolic region. Parabolic region. Next step. you'll find out the quadratic form of this equation, which is what? 1 lambda square plus, here was uxy. Be careful with that. Our equation was r plus s right? Where this r, s, and t were ux6, uxy, and uy. Uxy's coefficient we have to look, right? And checking also. So basically, this is uxx r plus ss plus tt, right? So it will become minus 4 of lambda plus 4 equals to 0. Let's find the solution of this. The stick solution will become lambda minus 2 whole square is becoming lambda equals to 2 you got. Now the differential equation. Plus lambda it is, which is 2. For the what? Characteristic equation. Solve it. Y plus 2x equals to some constant. For this guy. And eta equals to, you have to choose eta independent of xi. You can choose eta as x or y. But make sure when you find the Jacobian of the xi and eta, it must be a non-zero value. Let's find if we have put x over here. Jacobian of xi and eta, what is this then? Del xi by del x, del xi by del y. Del eta by del x, del eta by del y. 0 minus 1. Non-zero array, we will solve it, right? By this, what do you get now? You have to find del z by del x, del z by del y you've done, del eta by del x, del eta by del y you've done. You know the function as xi and eta, where xi and eta are the functions of x and y respectively. Now you have to differentiate, you have to basically find uxx, uyy, and uxy. So now ux is what? U xi into xi x, I can write it like this, or u eta into eta x. What does this mean? Del u by del xi into del xi by del x plus del u by del eta into del eta by del x. U xi, I don't know, xi x is the value 2. Plus u eta, I don't know, eta x is the value as 1. Am I right? Right? Now uxx. You have written outside u xi, I'm differentiating with respect to x, and I know u xi is again function xi and eta. So again, I have to differentiate it xi as well as with eta. So u xi into xi x plus u eta xi eta x plus, for u eta it will become u eta 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 x plus u eta xi into xi x. Right? Let's find the value and substitute. Xi x was 2, it will become 4. I'm just writing it very quickly, so do it carefully by yourself. Eta x is 1, so it will become u xi eta 2 times, 3 times. Okay. Xi x is what? 2. So 2 plus 2 will become 4. So eta plus u eta 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 x is 1. This we have got as ux. Now finding uxy. Ux I have done already, which is this. Now I have to differentiate this with respect to y. if I'm differentiating it with respect to y, I have to go this uzi along with xi along with eta both of the ways. So 2 times uzi will become what? Uzi psi of psi y plus u eta psi by eta y plus next is u eta. U eta I will differentiate with respect to psi first. Psi y plus u eta eta into eta y. Find out the values. Xi y and eta y. Xi y and eta y. Xi y is 1, eta y is 0. U xi, eta y has become 0. So u eta xi y is 1, eta y is 0. So basically uxy has become 2 times u xi plus u xi eta. This is state B, right? I'm finding u y y. Now u y is u xi of xi y. Xi y is what? 1. U eta of eta y. Eta y is 0. So uy is same as uzi. What will become for uyy? U xi of xi y plus u eta xi eta of eta. Correct? Xi y is, I know it is 1. Xi y is 1, right? So this will become u xi plus eta y is 0. So uy is again u xi, right? Now substitute the values. The equation is uxx plus 4uyy minus 4uxy equals to e to power 1, right? So uxx we have done uxx as 4 users I theta u theta 4 4 1. Uyy will become users I uxy has become 2 users I plus user eta e to power 1. Why I have to substitute in terms of psi and eta? What it will become? Be careful while doing it. Y is equals to what? If I look over here, if I have put eta equals to y, it would be very easy. I just had to substitute y as eta. But I have taken eta as x. So what I'll do is find out the value of y from here as xi minus 2x. And x I will put as eta. So y I have got as xi minus 2 eta. That's it. Solve it. Xi minus 2 eta. Xi minus 2 eta. Xi minus 2 eta. So if you look over here, 4 users I plus 4 users I, 8 users I will cancel out with minus 8 users I. U eta eta is here, 4 user eta, and when you open the bracket, minus 4 user eta. So what is left out is u eta eta as e to power xi minus 2 eta. That's it. Try by putting eta as y. Try it out. Okay. You'll get u xi here. Sorry. You'll get u eta eta, but this e to power xi minus 2 eta will change. Use check. Alright. So you can see what you will get. Alright. Moving forward, let's do the question based on the elliptic one. Let's find out the steps. For the elliptic one, for electric transformation. The last one is left. S square minus 4RT must be less than 0. This you will check. Second, find out the quadratic form again. It will. We know when we have this negative, that means some iota will come over here. Right? Be careful while doing the elliptic one questions. Basically, you have to be careful when you are finding the solution. In finding the solution, you have to check after that what will be your xi and what will be your eta. Alright, let's find it out. Here, that means you'll find again the characteristic curl r lambda square plus s lambda plus t. You will solve. Suppose you have got the solutions as a plus iota b and a minus iota b. You know the conjugate will be the root, right? So next will be the third part. You will find the differential equation dy by dx plus lambda 1. That means it will become a plus iota b and dy by dx plus a minus iota b. Alright. And you will find the solutions of these. They will be, suppose, in the form of fxy and gxy. And what you will do next? Here, instead of putting over here xi and eta as f and g, you will put xi as sum of f and g and eta as the difference of f and g. So that you will get one real value and another as iota value. So what you will do here next? For removing this iota, what am I doing is I'm dividing here by 2 so that my function will remain as f only the one function, and here I'll divide by 2 around. That's it. All right. Now start doing the question here. Let's try the question, which is example number 4.3.3. We have completed 4.3 after this example. So what you have to do, I'll tell you the questions which you can do based on this. Basically, this 4.3 includes constant coefficients of the small r, the smallest, and t. In the next section, 4.4, what we'll do is do the coefficients. Instead of constant coefficients, we'll take the variable x, y terms here. So your r, s, and t will consist of like x, y variables. The coefficients will not be the constant one. These kind of questions we'll do in the next video. Alright, so here I'll tell you which question you can try based on this section. All right. So the question, the differential equations for this example here is ux6 plus uyy plus uxy plus ux equals to 0. First step will be find out our s square minus 4id equals to 0. What would you get? Here is square minus 4rt. Check uxy here. 1 is the position here. In fact, 1 is the position 4. All the three values, right? Region is elliptic. What you're going to do? Find out the characteristic equation. Which is r lambda square plus s lambda plus t equals to 0. Will become lambda square plus lambda plus 1 equals to 0. Find out the solution. Minus b plus minus b square minus 2ac upon 2a. What will be the differential equation? Differential equations dy by dx plus lambda, right? Minus 1 plus root 3 iota upon 2. And the second will be minus dy by dx plus minus 1 minus root 3 iota. Right. Solving this, see, this basically iota term is a constant term. So basically it will become y plus minus 1 plus root 3 iota upon 2 of x equals to c. So basically it will be 2 pi minus 1. Should I solve it like this? Find it out. Minus 1 plus root 3 iota of x equals to some constant. Similarly, there's just one difference. It will become negative here. Correct? Now, if you say this is your complete first fxy, this is your gxy. And we know to find xi and eta here, I have to take the sum of f and g upon 2. And here difference upon 2 iota. Check what you're doing. Here. Consider P as y plus minus 1 plus 3 iota and q as 2y plus minus 1 minus 3. This is negative here. Be careful, you have to put negative sign in the denominator and substituting the value of beta. So put that as p plus q upon 2. P plus q, 2y plus 2y, it will become 4y, right? Plus minus 1 plus minus 1, it will become minus 2. Here x also there. Plus root 3 iota minus root 3 iota will get cancelled out. 2. So your xi will become what? 2y minus x. And eta will be p minus q upon 2, right? So 2y minus 2y will get cancelled. Minus 1 minus of minus 1. This will get cancelled. What is left out was root 3 plus root 3. 2 root 3 iota of x upon minus 2 iota. So it will become eta as minus root 3 of x, right? This will be the value. Now we have got xi and eta. So now we will get the last step, u xi eta. So uxx, uxy, and uyy. And ux was also there in the question. So this was the equation, right? So first we'll do ux. Ux was u xi x plus u eta x. Xi x is what? 2y minus x. And eta is minus 3x. So ux will become xi of x is minus 1, right? Minus of u xi minus of root 3 u eta. Now uxx will become again minus u xi of xi x is minus 1 plus u xi eta, right? Into eta x. Eta x is what? Minus root 3. I'm doing it really skipping the steps, but you don't have to do it. Okay. Minus of what? Root 3. Again, u eta xi x. Xi x is what? Minus 1. So I put minus here. Plus u eta of eta x. Eta x is what? Minus root 3. Right? And solve it. So uxx will become what? Plus the u xi plus root 3 plus root 3 plus 2 root 3 of u xi eta minus plus 3 times u eta. Right? Now let's do uxy. Uxy. That means this ux you have to differentiate with respect to y. So ux is what? Find out ux where you have done. Ux was this, right? So uxy will become what? No, you have to differentiate with respect to y, right? U xi y plus u xi eta y minus root 3 u eta y plus u eta xi. With the value of xi y and eta y. Xi y is in eta y. Xi y is 2, eta y is 0. So this will get cancelled. Eta y and xi y is 2, right? So minus 2 of u xi minus 2 root 3 of u xi eta I'm letting. Alright. Now this as b. What is left? Uxy. Uxy we have done. So u by y is left then. U by y, ux we have done. U by y. Now, uy is u xi of xy. Xy is what? 2. And eta y is 0. Xy is 2. I'm writing it directly. Just 2 u xi. Because u eta y is 0. Coming to u by y, it will become 2 times of u xi of xi y plus u xi eta of eta y. Eta y is again 0. Xi y is what? 2. So it will become what? 4 times u xi. Now this has C. Put the values in the given equation. The given equation is this, right? Control C. No. Put the values here. Uxx. Uxx is what? I'm just putting the values here, alright? You put the values by yourself, see what you're getting. U by y. What user is I? Plus uxy. Uxy is minus 2 root 3. User eta plus ux. Ux is minus user minus root 3. Minus user minus root 3 user equals to 0. See if anything is getting cancelled. C plus 2 root 3 user minus 2 root 3, right? 4 plus 1, 5 users I. U eta is there. Collect the like terms and basically add the coefficients here. See what you're getting. So we're getting 3 users I. U eta. U eta. Right? Xi done, eta done. Minus user minus root 3 u eta equals to 0. This is the equation that you've got. We have got user xi term, eta term, and user u eta, right? Function of sin eta. This was the case I've taken when we know the region is elliptic. So you have to be considerate when you are finding the region and you know that whether the region is elliptic, parabolic, or hyperbolic. So the equation, the transformation will be of these kinds. In hyperbolic equation, we have seen that u xi eta has come with u xi u eta has down. Here u xi comes, and here u xi and u eta both comes. Right? U xi u eta both are coming over here. All right. I'll tell you the questions which you can try. Okay. You can try complete question with 3 of these exercises. Right. We'll start with 4.4 in the next class.